Hello friends, today we are going to learn how to select belt from manufacturing catalog. In actual practice, designer has to select belt from manufacturing catalog. But to select the belt from manufacturing catalog, we need some important information. We should know power to be transmitted. We should know transmission ratio. We should know center distance, and also we should know type of a load. Without this, it is difficult to select belt from the manufacturing catalog. Now we'll see the procedure through example. Now see the problem. It is required to select a flat belt drive for a compressor running at 720 rpm, which is driven by 25 kW 1440 rpm motor. Space is available for center distance of 3 meter. The belt is open type. First we need to draw the open type belt drive system. This is the open type belt drive system. This is the smaller pulley, this is the bigger pulley, and this 3000 mm is the center distance. The belt is wounding over the smaller pulley and larger pulley. Now write the given data. Capital N, that is speed of bigger pulley 720 rpm, kilowatt equal to 25 kilowatt, that is the power to be transmit. Small n equal to 720 rpm means smaller pulley rotating at 720 rpm. C equal to 3 meter means center distance is given 3 meter. So whatever input data is required here given. Now we need to design the belt, means we need to find out the dimensions of a belt, means we have to find out the length, belt and thickness of a belt. Now we'll see the procedure step by step. Step 1, calculate assume belt speed by using the formula. First formula is V equal to pi dn upon 16 to 1000, where D is the diameter of smaller pulley, n is the speed of a smaller pulley. Tc equal to mv square, where Tc is the centrifugal tension, m is the mass of belt, kg per meter, and again v is the velocity of belt. Now simultaneously we are going to solve the problem. So in our problem, n small n is given, that is 720 rpm, sorry 1440 rpm, but here d is unknown, so we can't find out the velocity by using these two formulae because Tc is also unknown. If we are unable to find out the velocity by using the both formulae at that time, we have to assume velocity in the range of 18 to 25 meter per second. If we assume velocity 18 meter per second, then we'll get D equal to 238.73 mm. Now we'll move for the step second. Step second, calculate and select pulley diameter by using standard series. So to calculate pulley diameter, we are going to use transmission ratio, that is capital N by small n equal to capital D, sorry small d by capital D. And this is the preferred series for the selection of a pulley's diameter. Now in our problem, capital N is 720 rpm, small n is 1440 rpm, and small d is 250. So we'll get capital D equal to 500 mm as per the series we got the value of small d equal to 250 and capital D equal to 500 mm. But by calculation we got small d equal to 237.75 mm, but as per the series nearest value to the 237.75 is a 250. So here we have selected d equal to 250 as per the preferred series. Now step 3, calculate maximum power. So there is a formula, Kw max equal to Fa into Kw. Fa is the load correction factor. It depends on the applications. It varies from 1 to 1.5. Now our application is compressor. We are using belt drive system for the compressor. So here we are going to select Fa equal to 1.3. Now in our problem, power is given 25 and Fa equal to 1.3 as per this table. So Kw max equal to 32.5 kilowatt. Now step number 4. Calculate arc of contact for smaller pulley and select arc of contact factor Fd from the below table, from the given table. So alpha s equal to pi minus sin inverse of d minus d by 2c. So in our problem, capital D is 500 mm, small d is 250 mm, and value of c, that is center distance, equal to 3000 mm. So in this way we will get alpha is equal to 175.73 degree. And to select the FD from the table, so here we will not get 175.73 directly, so we have to select in between 170 to 180 by interpolation, means by interpolation FD equal to 1.04. Actually belt design on the basis of overlapping angle is 180, but in actual practice we never get exact 180 angle. If angle of lapping is less than 180, then there will be a rise in a tension of a belt. If angle of belt is greater than 180, then there will be a decrease in a tension of belt. To consider this factor, we consider contact factor. Now step number 5, calculate corrected power by using the following relation. Kw corrected equal to Fd into Kw max. So by interpolation we have taken this value, Fd equal to 1.019 and Kw max already we have calculated, that is 32.5 kilowatt. So finally we get Kw corrected equal to 33.78 kilowatt. Now step number 6, calculate corrected power rating by using following relation. So there are the two belt system, high speed belt system and four belt system. For our application we are going to use high speed belt system because we are using the belt in a compressor which runs at a high speed. Corrected Kw rating equal to 0.0118 V divided by 5.08. But now here we should use modified velocity. Modified velocity means we have calculated the diameter of pulley by using the formula and we get a diameter equal to 237.75, but as per preferred series we got a diameter equal to 250 mm. So there is a slight change in a diameter of the pulley. if diameter of pulley increases, actual velocity of the belt is going to decrease. So we have to calculate the actual velocity of a belt. This is called as a V modified. So we get V modified equal to 18.85 meter per second. Now corrected kW rating equal to 0.0438 kilowatt. Now we'll go for step number 7. Calculate the product of width into number of plies by dividing the corrected power by the corrected rating. So this is the formula: width into number of plies equal to corrected power divided by corrected belt rating. Number of plies means number of layers of a belt. If we use a one layer belt, then there will be chances of a shear failure. So for that purpose, we use a number of plies. Number of plies may be 1 to 10. So generally we assume number of plies equal to 4, 5 and 6 and calculate the different width of a belt for respective number of plies. So here for our problem, width into, we are assuming number of plies equal to 4 equal to 33.12 corrected power and 0.0438 kilowatt corrected belt rating. So finally here we get width equal to 189.04 mm. Now we are going to assume ply equal to 5. So for that ply equal to 5, we are getting W equal to 151.23. Now as per series, if we see for number of plies 181, there is no value, but for number of plies 5, nearest value for 151.43 is 152. So we are going to select width equal to 152. Now step number 8, calculate the belt length by using the following relationship: L equal to 2C plus pi D plus D by 2 plus D minus D bracket square by 4C, where C is the center distance, capital D is the diameter of bigger pulley, small d is the diameter of a smaller pulley. If we put the values in the formula, finally we will get the length of a belt equal to 7183.31 mm. So in this way we are going to fix the belt dimensions, length and width of a belt. Thank you.